morning to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering, MLR Institute of Technology. So in this lecture, we are going to discuss about the introduction of design and analysis of an algorithms. So coming to the overview of this introduction part, introduction to DAM, then what are the properties of an algorithm? So how to develop an algorithm for the given problem statement. So coming to the definition for algorithm. So what is the definition of an algorithm? Algorithm is a finite set of instructions. What is that instruction means? The statement which is written in the form of English language, like go to shop. Go to shop. It is an instruction. So these instructions, for what purpose we are going to write an instruction? To accomplish a specific task or a particular task. To perform a specific task, we have to design a task in terms of the set of instruction, that is called an algorithm. Then the second definition or second word for the design analysis of algorithm is, an algorithm is a method of representing the step-by-step procedure for solving a problem. For example, prepare a cup of tea. So first one is take a bowl, is step number 1. Step 2, pour some water. Pour some water. Then step 3, add sugar. Sugar, tea powder. Add sugar, tea powder. Then step 4, boil for some time. Then stop. So what is the procedure we are going to follow? Take a bowl is step. After that, pour some water, add sugar, tea powder, boil for some time. Then you have to stop. So this is the step-by-step procedure for solving a problem. Here, what is the problem here? Preparing a tea is a problem. That problem can be solved by using the step-by-step procedure. This is called as an algorithm. Then what is the definition of an algorithm? Algorithm is a method of representing the step-by-step procedure for solving a problem. And coming to the third definition for an algorithm is, it is the method of finding the right answer to the problem. That is, suppose if you want to solve a problem, first you have to design a problem, or you have to write the step-by-step procedure for finding the solution to the problem. That is called as an algorithm. So simply we can say that an algorithm is a step-by-step procedure for solving a problem. So before designing an algorithm, we need to check whether these properties are satisfied in the algorithm or not. These are 5 properties for the given algorithm. These properties should be satisfied in the given algorithm. First property is an input. So an algorithm is, suppose you have to design an algorithm, that algorithm should take 0 or more quantities are to be given. For example, if you want to find the solution for addition of 2 numbers. For addition of 2 numbers can be supplied as an input. 2 numbers can be supplied as an input. So for solving a problem, we are going to give the input. So the input should be accepted by the algorithm. That may be 1 quantity or 0 quantity or more number of quantities. In this, the quantities, 2 numbers is a quantity. For example, sometimes you are going to print hello world 10 times. Print hello world 10 times. Here, what is the input you are going to supply? Nothing. That is the 0 quantity of input. 0 quantity. But they are taking some input as addition of 2 numbers to quantity. Quantity is 2. So we are going to give the input to the algorithm. So algorithm should take an input. That is the first property. Second one is the output. So at least 1 quantity of output should be produced. So if you take the addition of 2 numbers, 2 plus 3, what it gives the result as 5. 5 is the output. 5 is the output. How many quantities of output is generated? At least 1 quantity of output should be generated. That is the second property of an algorithm. Definiteness. That means each instruction is clear and unambiguous. Unambiguous means there is no conflicts between the statement. So that is nothing but the third property, definiteness. So that is, for example, we write the instruction as add some water. So this, whatever the input instruction we are going to give, that is related to the previous instruction. For example, for preparing the tea, so we need some water. That is the related. It should be clear. Without taking, suppose you are going to perform the addition of two numbers. So 2 plus 3, take input as 2 and 3, add some water. It is not a clear instruction. Each instruction should be clear and it is not conflicting with other instruction. That is the definiteness property. Next, finiteness. If we trace out the instruction of an algorithm, so it should be terminated after a specific number of steps. For example, for I equal to 1, I less than or equal to 5, I plus plus. Here, what is the initialization? Initialization is 1. I less than or equal to 5 means it is a condition. When this algorithm, when this for loop is terminated after 5 steps, I equal to 1, 1 less than or equal to 5, condition true. Then 2 less than or equal to 5, 3 less than or equal to 5, 4 less than or equal to 5. So after 5 iterations, the algorithm should be terminated. That is, a algorithm, you are going to design an algorithm, then it should satisfy the property of finiteness. That means it is to be terminated after a specific number of iterations. For example, I less than or equal to n. N is not defined. Suppose n is not defined. We don't know the value of n, then the finiteness property is not satisfied. Because once we know the value of n, then we know that when it is going to be terminated. But if we don't know the value of n, then it is not a finiteness. Then that is the fourth property. An algorithm should be terminated in a finite number of steps. Next, effectiveness. Every instruction must be very basic so that it can be carried out in principle by a person using pencil and paper. Whatever the instructions we are going to give, that should be written with the help of pencil, or it is pencil and paper. For example, suppose you are going to perform the addition of two numbers, 2 plus 3. Generally, you are going to write A plus B instruction. But whatever the input you are going to give, then everything should be produce the corresponding output. For all input, it could produce the output for any type of input. Like that, you are going to design an algorithm. That means it should be effective. It should be effective means then whatever the instruction you are going to design, that should be solve all type of inputs. It is a integer numbers, or it is a floating numbers, or it is a decimal numbers, whatever the input, but it produce the correct output for any type of input. These are the 5 properties of an algorithm. First one is the input, second is output, third one is finiteness, the definiteness, and fourth one is finiteness, and fifth one is effectiveness. Next, coming to the pseudocode. What is the difference between algorithm and pseudocode? And then, so that is a flowchart. So this algorithm is represented by using two notations. One is called as a pseudocode. Another one is called as a flowchart. There are two notations for representing an algorithm. One is called as a pseudocode. Another one is a flowchart. What is the pseudocode means? Generally, we are speaking English. The English language is used for writing the instructions, then it is called as a pseudocode. So that is a general English statements. So that is nothing but read the numbers, compute the numbers, like that. General English language statements are used for representing the algorithm, then it is called as a pseudocode. What is meant by flowchart means diagrammatic representation of an algorithm. For example, so step 1, start. The start is represented by using this symbol called rhombus. This is start. This is the symbol for start. So we are going to use the symbols for representing an algorithm, then it is called as a flowchart. What is the meaning of pseudocode? Means an algorithm is written by using the English language statement, then it is called as a pseudocode. Next, so coming to one example for the pseudocode, how we can write the set of instructions using the pseudocode. So step 1, read the numbers of A, B, C, D. Reading the numbers, that is the English statement. Compute the sum of A, B, C. Compute the sum of A, B, C. So A plus B plus C. Then divide the sum by 3. A plus B plus C divided by 3. Then store the result in D. D equal to A plus B plus C by 3. Then you have to stop. This we are using some English statements, okay, or any standard representation. Here reading the statement, compute, to divide, store the result. This is the English language statement. These English language statements are used for representing the algorithm, then it is called as a pseudocode. Now, once we are going to representing, now we are going to start the development of an algorithm. So, we are going to follow some development steps for development of an algorithm. Once the algorithm is designed, then we are going to develop an algorithm. There are 6 steps are involved for development of an algorithm. First step is specify the problem statement. Second one is design an algorithm, designing an algorithm. Third one is coding. Fourth one is debugging, testing and validating, and sixth one is documentation and maintenance. Now coming to step by step, so what is meant by specifying the problem statement? What is the meaning of designing, coding, debugging, testing and documentation? Coming to the first step, first of all we need to analyze the problem statement. For analyzing, first we need to read the problem statement carefully. Read the problem statement carefully. So what is the meaning of analyzing the problem statement? Means what is the input that is given, what is the output we are going to produce, what are the requirements for satisfying the input and output. Everything should be thoroughly we can understand before solving the problem. So first step is specifying the problem statement. So that means whatever the problem we are going to solve, we need to understand so what is the problem that has given. Then we are going to analyze what is the given input, what is the output that is to be expected. So what are the requirements for solving this problem? Everything we need to understand in the case of step 1. Once the problem is thoroughly understood, then we are going to design an algorithm. So designing an algorithm means there are several methods are there for designing an algorithm. So some strategies in the algorithm is a divide and conquer strategy. Divide and conquer strategy. That is one type of strategy. Second one is a backtracking. Backtracking. Greedy approach. Greedy approach. Then dynamic programming. There are different strategies are there. So different strategies having the different type of solutions to solve a problem. But whatever the solution, whatever the strategy we are going to select, that should be understandable. That should be understandable. So second statement is once the problem is analyzed, then we are going to start designing an algorithm. For designing an algorithm, there are different strategies are there. So we have to take any strategy for developing an algorithm based on the given problem statement. For example, if it is a merge sort, that merge sort follows the strategy of divide and conquer. Suppose knapsack problem is there, that follows the strategy of dynamic programming. Like that, different strategies are providing different types of solutions. So once the problem is strategy is defined, then we are going to design an algorithm or it is a flowchart. So we have to representing that step-by-step procedure in terms of the flowchart or it is a pseudocode. Both are the representations for designing an algorithm. Then after writing the step-by-step process, converting that statements into a programming language. For example, read ABC. So this is a statement. We have to design algorithm like read ABC. This read ABC should be converted into a programming. So for example, in the case of C programming, we have to write scanf %d, 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 ampersand of A, ampersand of B, ampersand of C for reading the values of A, B, C. So once the algorithm is written by using some algorithmic strategy, after that we are converting that algorithm into a program by using the programming language. That process is called as a coding. That process is called as a coding. Converting the given steps into a programming language format, that is called as a coding. That means we have to return the program. After return the program, we need to check is there any mistakes in the program or not. So everything is correct or not. That is called as a step 4. So what is that step 4 means? Debugging. Bug means error. Bug means error. Debugging means debugging is the process of removing the errors. Debugging is the process of removing the errors. So we need to check whether that algorithm is program is written correctly or not. Is there any mistakes in the program? We need to verify by compiling the program or by compiling the program. In the case of C programming also we need to compile the program. So once we compile the program, we are going to identify the errors. The process of checking the errors in the program is called as a debugging. There are 3 types of errors are generated during the execution of the program. First one is called as a syntax error. Syntax error. So that is a syntax. Syntax means we need to follow some rules. So how to write the while loop? While I less than or equal to n is a condition. It is a condition. So in the case of while accepting the condition, while within the while statement you have to write the condition. That is the syntax we have to follow. Then suppose instead of while nothing is returned, then it is a syntax error. It is a syntax errors. Then A equal to B equal to. So A and B values are not initialized. Then it is not follow the syntax. So what is the syntax errors means? According to the rule, if the statement is not written in the proper format, then syntax errors are generated. Second type of error is called as a logical error. Second error is a logical error. So I want to write a program for factorial of a number. It should follow some logic. So for I equal to 1, I less than or equal to n, I plus plus. For I equal to 1, I less than or equal to n, I plus plus. Fact equal to fact into I. It is the logic. Okay, logic. So if logic is not followed, if the logic is not followed in the program, then logical errors are generated. If the rules are not followed, syntax errors are generated. What is the logic in factorial of a number? Fact equal to fact into I. So we need to initialize the fact value as 1. If it is not defined, fact value. So what is the initial value? It is going to be considered. If the logic is not defined correctly in the program, then logical errors are generated. And the third type of errors is runtime errors. Third type of errors are runtime errors. That means divide by 0. A divided by 0. A divided by 0 is a, so that is a runtime errors. So runtime errors are identified during the running of the program. Syntax errors are generated during the compilation of the program, whereas logical errors are generated. Logical errors does not show any error, but we are going to get the wrong output in the results. So that is the fourth step is debugging. So fifth one is testing and validating. Once the program is written, then you are going to convert that convert the step-by-step procedure into a program. Then after that we are going to check the errors in the presence of program. After that, everything is over, then we need to test the program. So testing means we are going to give different types of inputs, different values of input, different types of inputs. One is a integer number as a input. Integer numbers as 2, 3. Whether 5 is produced correctly or not. If it is a 2.0 or 3.0, whether 5.0 is generated or not. Whatever the type of input, whatever the value of input you are going to give, whether our program is producing the correct results or not, that is called as a testing and validating. Testing and validating. It must be tested means it should go through the different types of input. For whatever the inputs you are going to give, whether the program producing the correct results or not, called as a testing and validating. And the sixth one is a documentation and maintenance. So documentation and maintenance means whatever the program you have to return, we need to collecting and organizing the data in the form of documentation purpose. That means we need to save the program for further reference. So today I have done the program as that is a reverse of a number. For future reference, I am going to use the same logic for finding the Armstrong or it is a palindrome. The same logic I have used to in the reverse of number. So same logic is applied for the Armstrong or it is a palindrome. First of all, I want the reference. For that reference, I need to save the program in some drive or it is a folder for the future references. That is called as a documentation and maintenance. Documentation means the process of collecting the data, organizing the data for future reference, then it is called as a documentation. Based on the reference, we are going to do the modifications in further or it is a future, that is called as a maintenance of the program. We are going to do some updations in the program, that is called as a maintenance. So what are the 6 steps in the case of development steps? Specifying the problem statement. Second one is designing an algorithm. Third one is coding. And fourth one is debugging. And fifth one is testing and validating. And sixth one is documentation and maintenance. So up to now what we have discussed, what is the definition of an algorithm? Then what is the definition? An algorithm is a step-by-step procedure for solving a problem is called as an algorithm. Then after that we discussed about the properties of an algorithm. There are 5 properties are there. One is input, then output, finiteness, definiteness, then effectiveness. These are the 5 properties of an algorithm. And also we discussed about development steps, how the algorithm is developed. There are 6 steps are there. One is nothing but first one is specifying the problem statement. Second one is, second step is writing the algorithm, that is designing an algorithm. Third one is coding. Fourth one is debugging and testing and validating and documentation and maintenance. These are the program, that is program development steps. How the algorithm is to be designed, how the algorithm is designed to develop a program. So thank you.